This is a demonstration of log graphing and using it to estimate the exponential relations between two variables in the Mei C2 syllabus, and I'm going to use the June 2014 question 13 as an example. These all come up in a fairly common format. If you've done physics or chemistry and done experimentation, then you'll probably have been through this anyway, but it's worth repeating it as it comes up each time. They have a pretty standard form. You'll get a table of information at the top. You may well get asked to do a piece of maths, as in Roman 1 here, excuse me, Roman 1 here, to reorganize the original formula into a log form. They will then ask you to actually tabulate the data, graph the data, and most likely put a best fit line into it. And at the end, they will ask you to then estimate the value at a particular point, either within the range we've got above, interpolation, or going outside, extrapolation. And at the end here, they've got a 1-pointer, which looks like an A-star question, which is an interpretational question of why this may or may not be reliable. So that is basically the standard form, and you just need to be able to repeat this. There's only two types of relation they will do. It's either a value to a log or a log to a log, depending on the type of model they're going to use. And in this case, we got a value to log 1, but they'll tell you which one you're going to do. So there's a bit of an introduction. Now let's look at this individual question and see what it's asking us. And as ever, we start by reading the question starting the start. Right. The thickness of a glacier has been measured every 5 years from 1960 to 2010. Table shows the reduction, worth bearing in mind it says reduction in thickness from its measurement in 1960. So here's all our years from 1965 all the way to 2010, and now we've got two variables, and they've given us time, t, as the number of years since 1960, so that makes life easy to graph, doesn't it? 5, 10, 15, 20 years to calculate with, and so that's effectively going to be our x value. It's going to go along the x-axis, and then we've got the reduction in thickness since 1960 in meters, so that's going to be our y value, but we're going to have to use an exponential in a sec. So what does it say? An exponential model may be used for these data, assuming the relationship between h and t is of the form h equals a times 10 to the power bt, where a and b are constants to be determined. Okay, it's life easy. Show that, and just so before we go on, just to say that's giving us one of these formats, which is a value as our h, and on the right we've got a power. So we've got a value to power relationship, and they're going to ask us to turn it into logs. So show that this relationship may be expressed, this is a Roman 1, show that this relationship may be expressed in the form log 10, log base 10 of h equals mt plus c, stating the values of m and c in terms of a and b. So first thing we've got to do is to calculate that. So let's have a quick whiz down. H equals a. Let's start with our original formula. This is part 1. H equals a times 10 to the bt. And what are we going to do? We want to get that t down from its exponent form, so we're going to log it. What are we going to log it to? So we're going to log it to a base, a convenient base. Here we can see that convenient base is base 10 because that's what the exponent's in. So let's log the whole equation to base 10. There's our h on this side. That's our log to base 10 of a times 10 to the bt. Okay, using all our log laws, right hand side doesn't change, that's log 10h. On the left hand side, rather, the right hand side, we can break it up because we've got a log of 10 to the a plus bt times log of 10 to the 10, which we all know a log of a number to a log of a number to its own base is always going to be 1. So that's made our life easy. So what we've now got, let's just reorganize into the form that they're looking for us to have. We've got the right form on the left hand side of this equation. So when we log to the base 10 of h equals bt plus log of 10a. Then we're going to do matching terms because they want us to put it in the form mt plus c. So we can see here that m equals b and c equals the log 10 of a. So let's just show what we're doing there. We're matching those terms here. So I think we just answered question Roman 1. That's what they wanted us to do. Okay, what are we going to do next? Part 2. Complete the table of values in the answer book, giving your answer correct 2 decimal places, and that's the first part, and then plot the graph drawing by eye line of best fit. So drawing by eye, let's try and break it out so we can see the bit. Line of best fit. So we've got 2 activities to do. We've firstly got to create the table of values, and secondly we are going to plot it and draw a best fit line. Okay, so this looks like most of the question here in terms of spade work, doesn't it, for our 4 points? Okay, so in the exam they give you a table here to complete. So let's have a look at it, and they've kindly transferred all the data down for us, so that makes life very easy. We could go over to this page, couldn't we, complete it. So getting our trusty calculator out, we can find that the log to base 10 of 0.7 is minus 0.15, and they asked us to do this, wasn't it, to let's have a look, 2dp, wasn't it? Let's just whiz back up and have a very quick look. Quote 2 decimal places, yeah, there we go. So we're doing, should put that there, so we complete the table to 2 decimal places. So as you can imagine, I could carry on and do all of these numbers, and I'm just going to fill them in quickly whilst I pause the video. So there are the figures, all ready to go. Our next step is they're going to ask us to plot them, and they've kindly provided an outline graph to do so. So here's the graph all ready for us, and we need to start plotting points. So if we started off with our first point on the left hand side here, we're going to plot our point, which is 5 minus 0.15, which is there, and 2 down. Excuse me, it's going to be really tiny. I've had to make this tiny to see where we are. So there's my first point, and I'm going to go through and plot all the points so you can see them. So there are all the points, and they've given us a pretty nice, closely correlated set of points there, haven't they? And it's clearly a linear relationship. Now we've got to the log, and that means that we can fit a best fit straight line through those points just by eye, and that's all it asked us to do, was by eye. So there's a bit of flexibility here in the answer as to exactly what that number is, because they've got to have a range of accuracy. So I'm going to go through and fit a point, thinking about looking for a point that line that goes pretty well, quite close to the 2 end points adjusted for the middle. So there's my idea of the best fit line. Make sure that you draw your line, particularly if it goes down here to the x equals 0, so you've got an intercept point at the bottom left here, because that's going to give you your constant. Okay, so what you have to do from here is let's just go back and check the question, see how far we've got into it. Drawing by eye. So I think we've completed that section. We've done our best fit line question. That part of the question, we're going to get 4 marks for that. Now use your graph to find h in terms of t for this model. Okay, use your graph. Okay, well, we've created a best fit line there. That was our green line. So what we now need to do is to create a relationship based on that best fit line. Okay, and they gave us before, didn't we? We created a formula, b equals, so log 10 of h equals, wasn't it? It was mt plus log 10 of a. So what have we got to find? We've got to find the values of m and log 10 of a. Well, m's our gradient and log 10 of a is our intercept. So our intercept here, using my figures, is minus point, an intercept point here is minus 0.27. That's what I would get for that. And then we need to pick a gradient, and probably want to do that over as much of the length as we can here. So if we went from one end to the other, there's 50, t goes from 0 to 50 years, and our range here, I'm just going to write it on the side, so over 50 years we started at minus 0.27. So our difference, that's going to be the bottom of our difference calculation, and the top end, I think we're at 1.38. So 1.38 minus 0.227, 1.38 plus 0.27 is our up. I'm going to divide that by our long, which is 50, so I wrote 55 there, but it's actually 50. In my terms, that's going to give us 0.033, so that should be at 50 there, because that's the number of years. There's our 50. So just writing that out in here, 0.033 mt, sorry, 3t, there we are. And we calculated before that would, so when we had the gradient m, we should really have written b, because that's what we had in our formula before, wasn't it? B, there we go. So we now know b and log of 10a, and we now need to just rewrite that formula back into the form that we started off with, 10a to the power bt, which would equal, well, we can see our b there is 0.033t, and we've got our log 10a equals minus 2, log base 10 of a equals minus 0.27, and we can reverse that process by just doing a power, can't we, to find our value of a. Let's quickly just write that there. So a equals, therefore equals 10 to the minus 0.27 equals 0.537. So putting that in the formula, 0.537 times 10 to the 0.33t, that will be our relationship. Sorry, I'm just going to do a very quick correction to my calculation, because that was, of course, 1.28. 1.28, which meant that my gradient here was minus 0.31. Putting that into the formula down here. Let's just do that correction. 0.31. 0.31. And that's going to be 0.31 there. Let's just do that. So it's going to be 31t. 31t. I'm sorry, and the reason I'm doing that is just so you can see here. I've put in yellow now. Obviously, this is not an exact science, and I've put in yellow there the examiner's range that they would have accepted from your best fit. So you could have, for the gradient, you could have had the range 0.028 to 0.032. That was quite a big range. And for the value of A, once it had been powered up, you could have had a value being 0.5 and a 0.6. So that's quite a wide range, isn't it? Okay, let's get on to the next part of the question. Let's see what we've got. So we're doing pretty well so far. I got most of the marks. Part 4, calculate by how much the glass will reduce in thickness between 2010 and 2020 according to the model. So it's according to the model, not the graph, not the actuals, but the model, and it's the reduction when you're doing the calculation. So we're going from 2010 to 2020. Let's do that. So let's pick ourselves up and see what, so we can still see our formula at the bottom, at the top here. This is 4. So we're looking for the model reduction 2010 to 2020. So that's from t equals, let's just check looking at our graphs, going up from, going right to the top so we can see it, from 50, t equals 50 to t equals 60, yeah? So 2010 is when t equals 50, and 2020 is when t equals 60. So putting those values into our formula, we're going to get h at 50, and we're going to get h at 60, and the difference we're going to calculate is going to be h 60 minus h 50. Yep, that's the difference between the two. So if we put these figures into our formula, 537, 10, 0.31 times 50, and the other one's going to be 0.537, 10 to the 0.031, times 60. So our two values are 19.05. I'm going to do it to 2 decimal places, and then we'll sort it out at the end. And 38.90. So the difference between those two is going to be equal to, so I'm going to take this down, so that's 19.85, but I'm going to take that down to 19.9. That's meters, isn't it? I'm going to use that because I think 19.85 is well beyond any reliable level. On the graph, we were only really able to identify to 1 decimal place. So I think that looks like a realistic assumption. You're not overstating it. So that's 19.9. looking at the range of answers, you'll see firstly that at the bottom here I put in yellow. So the range is very wide, between 8.0 and 26.1 meters, depending on the values of A and B you'd calculated from your graph. And you'll see they've done that to one decimal place, which fits in with the reliability of your answer from the graph. So we're pretty well done here. We had quite a lot of latitude on the answer there, didn't we? And that was worth, what was that worth to us again? That was worth 2 marks, putting in those 2 formulae. It was important that you set out the way you were doing the method and the formula. Okay, final part, question 5. Give one reason why this model will not be suitable in the long term. So they're only giving us 1 point, 1 reason. So one reason not suitable in long term. So we need to, in this question, interpret the real situation. It's not asking us for anything statistical or anything like that. It's asking us to interpret the situation we're in. And what do we have here? We've got the ice is reducing, isn't it? It's melting, and ultimately, and what we're seeing is an increasing rate. Yeah, that's what we saw. That's what that relationship gives us. So it's at an increasing rate according to the model, in the model, but ultimately, if you just think it through in the circumstance, all the ice is going to melt. Ultimately, the ice is going to melt. All the ice will melt. When all the ice melts, the reduction will go back to 0, won't it? So, so the reduction will be 0, and therefore model won't work. No longer valid. Yeah. Because this is an accelerating model, and at some point it's just going to hit the end. So there we are. We've got a point for that as well. So ultimately, these are pretty structured, aren't they, in their questions, and they're going to take us on the journey, and it's just like carrying out an experiment in physics or chemistry. Finally, here's my little summary sheet of things to bear in mind when you're doing these questions. Firstly, the question will set out the relationship, and you're going to have one of 2 forms of relationship. So if they give you one of these, it's y equals k to a to the power x, so the x is in the exponent, you're going to be asked to draw a log graph where x equals some m of log of y plus c. Or they could give you an equation where y equals k x to the power n, in which case you're going to do a log-log graph of logging y equals n times log of x plus log of the constant. So you're going to do one of those 2. They're going to take you through the standard form of, you're going to create a table of values, you're going to plot the values, you're going to draw a line of best fit by I, and that's your graphing. You're then going to use the intercept and the gradient of the graph to calculate the constants for your line of best fit. You're then going to be asked to calculate some values of y from the formula, not from the graph. Go to the formula that you've got up the top there. Now you know what the constants are and you've put them in. And finally, you may be asked to comment on the reliability of using the formula in any particular area of the range, particularly extrapolation to outside the range and over the long term. So I hope that's useful, and best of luck.